All right, we'll go ahead and get started. Um, Today I want to go over quickly kind of what's on your screen, and you've seen this a couple of times so far already. So this is nothing new. This is just a brief recap of what we've done so far with trig. Okay. After that, I want to take some questions that I see in the discussion board, which it doesn't seem like there's many, but I'll try and recheck that here in a second. Um, After that, if there's no other questions about anything we've done so far, uh, we'll move into some new stuff, which is dealing with triangles that are not right angle, which are not right triangles. Okay, and you will have homework over that. I'll go over a couple of examples that you will see on the homework, um, and you should have about 30-ish minutes to work on this within this class period. All right. Um, so give me like 30 seconds to re-look through the discussion. Um, and I'll address those questions and then we'll move on. Also, I guess before I do this, make sure your homework is submitted to on campus. Please do not email me with that. When you email it to me, it's in two different spots, and I want it all in the same spot. I don't want to have to go through my email with a bunch of different people just to get to your name. So please submit it to on campus. All right, so a couple questions on the homework, um, but it mainly had to do with dealing with things with both a whole number and a radical. Um, it's it's also kind of dealing with rationalizing, all right, and dealing with square roots, but it's getting to the kind of the harder problems. All right, so this is number I think 5 or 7, I believe. Um, so both the numerator and the denominator have a whole number and a radical. The first thing we need to do is to simplify what is simplifiable, right? So there's the 10 over 8. And if we do that, if we just simplify that part, we get 5 over 4. And one thing that a lot of people were doing, which I actually I thought it was pretty clever, um, they were simplifying this as well, the square root of 20 and square root of 15, which you can actually do, right? So if we simplify that, if we just ignore those square roots and pretend that they're numbers on their own, we get square root of 4 over square root of 3. Right? Because 20 and 15, we can factor out 5s from each of those, and then we get square root of 4 over square root of 3. And now it's just, we rationalize. Okay, so we have 5/4 times rad 4 over rad 3. In order to rationalize, we have to multiply by rad 3 over rad 3. On the top, this 5 remains the same. Rad 4 times rad 3 is rad 12. Actually, I'm going to simplify that just a little bit more. This rad 4, the square root of 4 is 2. So then this really becomes 5 times 2 times rad 3. And then the bottom, again, the 4 stays there. Rad 3 times itself just becomes 3. And then we can simplify and kind of make it look nice, right? So 5 times 2, that's 10. So in the numerator, we have 10 rad 3. In the denominator, we have 12. And then we simplify those whole numbers once again. So we get 5 rad 3 over 6. All right, so questions over that example. Where's the assignment for the worksheets? It wasn't on my on campus. It is. I had it due at like 8 a.m. though, so people would actually do it before this class so I could look at it. Okay, so if you didn't see it, chances are you waited to the last second. All right. That was pretty much the entire, like, I think that wraps up pretty much all the questions, right? It deals with square roots, and it deals with rationalizing a little bit. If I need to go over this a little bit more, I will do that, but we can do that in teams a little bit later. And if you still have questions over this homework after this lecture, we can talk about it there. Okay, so that's fine. I haven't like put in the grade yet, so don't worry if it's not 100% complete, like it should be. But we can kind of make it right and really understand it here in the next, like, within this class period. Okay. So with that, are there any other questions over this worksheet? All right, then. Let's just review, just to recap what we've done so far. All right. So again, you've seen this. You don't have to write this down. You've probably seen it 2 or 3 times. This is in total what we've done so far. So we've labeled sides of a right triangle. We've used the Pythagorean theorem. We've gotten trig ratios. So SOHCAHTOA, sine, cosine, tangent. We've also done reciprocal functions, cosecant, secant, and cotangent. We have found angles using inverse trig. And we've, in general, since kind of the beginning of this chapter, been rationalizing and dealing with square roots, which is probably, honestly, the most confusing part in all this. It's not necessarily straightforward. There's not always just one way to do it. But that part takes practice, which is kind of what we're working with. Okay. And then we've had problems where we're dealing with angles of 30, 45, and 60, in which case we're using these values. All right, so that's, again, quick recap. It seems like everyone's kind of getting this. And again, if you aren't, we can ask questions about it a little bit later in teams, okay? But everything we've done so far is dealing with right triangles, okay? So all of this only applies, for the most part, to just right triangles, triangles with a 90-degree angle in it, and that's it, okay? Once you go to an obtuse triangle or an acute triangle, none of this really works, okay? Which is what we're going to do today. We're going to look at triangles without a right angle, and there's really only one concept that we need to know, which is called the law of sines. All right, so the law of sines says that if we have a triangle without a right angle, right, as shown, we can split it up into ratios of angles with their opposite sides. So I'll give a second for people just to write that down real quick. And it's very helpful to have this image with this equation. So take a second, really write it down, and then I'll talk about it. All right, so in this triangle, we have different angles. So we have angle A, whose opposite side is side length A. We have angle B, whose opposite side is side length B. And then we have angle C, whose opposite side is side length C. Okay, so kind of just like when we started trig, labeling sides is super important. Okay, so if you can track down opposite sides of certain angles, already you're doing really well. All right, and with all of that, we can solve for certain sides or certain angles using this rule right here, which is just ratios of the sines of angles divided by their opposite side. So in this blue, we have the sine of this blue angle divided by this side length is equal to the sine of this angle divided by its opposite side length, which is also equal to the sine of this angle C, over its opposite side length. All right, so we're going to use this to solve for different sides or different angles of triangles that don't have a right angle in it. Does anyone, like, I'll leave this up for the next like 10 to 15 seconds, and then we're going to move on. If there are any questions about that, please let me know, and then we'll do examples kind of to show what it's actually doing. All right, so let's use this in an example, and I'll have this up on this next part. Okay. So given some triangle, given some figure, with two angles and a side, we need to find another side. All right. So we are given an angle 123. That angle corresponds to the opposite side of T. We are given an angle of 30, which corresponds to the opposite side of U. And we are given an angle V, which corresponds to an opposite side length of 12. Okay, and that's just making sure you're clear with what angle is opposite to what side. Okay, then we just kind of plug into our equation, right? So sine of t divided by its opposite side length will equal sine of v over its opposite side length, which will be equal to sine of u over its opposite side length. Okay, so that'll be kind of the equation we're working with. Now, given any two angles in a triangle, we should always be able to find the third. And I probably should have done this first. But we have an angle of 123, an angle of 30, plus our unknown angle. That has to be equal to 180. So if we solve for that, we get angle V is really equal to 27. So we actually do know this angle, even though it's not explicitly given. All right, so then we can kind of plug in what we have and see what we don't and see what we need. And keep in mind, throughout all of this, we're trying to find this t. We're trying to find that side length. All right, so if we start, we have sine of 123 divided by the side length of t is equal to the sine of v, which we found to be 27, over its opposite side length, which is 12. And that is equal to the sine of 30 over its opposite side length, which we do not know. Okay, so I want to pause there for a second. Are there any questions over anything that I've gone over so far? Okay, so now we can start to kind of do some calculations. Now, because we are solving for t, right, we're solving for this unknown right here. We can only have one unknown. All right, so because there's another unknown right here, we can get rid of that part of the equation. So we're not going to worry about this part in green. We're just going to worry about blue and about red, because we're just trying to solve for t here. And when we do that, we have to solve this proportion. So if we cross multiply, we get sine of 123 times 12 is equal to t times sine of 27. And we still have to get t by itself, so we have to divide by sine of 27 on both sides. And when we do that, we get t is equal to sine of 123 times 12 over sine of 27. Why is the sine of u canceled? Again, we're just trying to solve for this unknown. So whenever we're just trying to solve for one unknown, there can't be any other unknowns. And in this green part, there's another unknown. So it wouldn't make sense to use that in order to solve for t. So we just ignored it. Okay, so then we have an expression for t. We have that t is equal to sine of 123 times 12 divided by sine of 27. Okay, and then we can kind of go to a calculator and get an answer. But before we do that, are there any questions about what I've done so far? All right, so then we can go over to a calculator, type this part in, and get an answer. So I'm going to pull up Desmos, and I will write it exactly as I would in a normal calculator. But you can see both. Okay. So on a calculator, we want to type in this right here. Okay, and we have to be very careful when we do that. So normally I like parentheses around my numerator and parentheses around my denominator. Okay, so I'm going to start typing in parentheses sine of 123 times 12, close that numerator parentheses, and then divide that by sine of 27. Okay, now, before you hit enter, which this answer really doesn't make sense, and that's because we're in the wrong mode. So really the first thing you should do is go to your mode or your wrench icon, click it, and then go down to degrees, click on it, and then you'll get the right answer. So the answer to this is 22.167. And this problem says to solve and round to the nearest tenth. So really our answer is 22.2. So if you're on a TI-84 or TI-83, again, you type it in pretty much as is. But in order to change the mode, you hit the mode button. You scroll down to where it says radian and degree, highlight degree, and hit enter. But right now, both will work. Honestly, though, the more familiar you are with your TI-84 or TI-83, the better, because that calculator is legal on the ACT, and you can very easily use that to get a couple of free points and save quite a bit of time. Okay, you won't have Desmos with you. Okay, so I want to pause there real quick. Are there any questions over what I've done so far? All right, so let's do another example. How many decimal places are we supposed to go to? It'll specify. Just got to read the directions. I think normally it's the 10th, but it might be different. Okay, so in this example, again, we're given a triangle, and we're asked to find a certain side. Okay, so what I like to do, one, I have our law of sines written, but it's good to draw it out too. So sine of 34, or rather 34-degree angle, that corresponds to the side length of 14. The angle E corresponds to the side length E. And the angle 19 corresponds to the side length F. Okay, so if we set up our law of sines with this figure, we get sine of G over G is equal to sine of F over F is equal to sine of E over E. And as I'm saying that, just so you guys know, there is a difference between the uppercase F and the lowercase f, the uppercase G, the lowercase g, and the uppercase E and the lowercase e. Uppercase letters normally refer to angles, lowercase normally refer to side lengths. Okay, once we have that, we can substitute in what we know. So the sine of G is really the sine of 34. The G length is 14. Sine of F is really sine of 19. F is unknown. And both of the E's are unknown. Okay, so we could find the E angle, but because there's already an unknown in that equation that we're not solving for, we can just ignore it. So we're not really canceling it out, we're just ignoring that part of the ratio. Okay, so now, though, we have a ratio that we can solve for. So before I go any further, are there any questions over what I've done so far? Right, so then we just solve for F. So if we cross multiply, we get F times sine of 34 is equal to 14 times sine of 19. Again, we have to solve for F, so we need to get that on its own. So we have to divide by sine of 34. So then F is equal to 14 times sine of 19 divided by sine of 34. And then we can go to a calculator, type it in, and get an answer. Okay, so when I do that, type in parentheses for the numerator, 14 times sine of 19 divided by sine of 34. So when we hit enter, we get 8.15. Again, I think this says round to the nearest tenth. So our answer is 8.2. So that is the F side length. Okay, questions about that problem? All right, so I'll do one more example. And I'll do this one just a little bit quicker. I'll save a little bit of time. But just enough so we can actually see still what's going on. So this says to find u. All right, so I'm going to set up my equation. All right, so when I do that, I get sine of 80 over 16 is equal to sine of 41 over u is equal to sine of v over v. Okay, and again, we're just looking for u, so any other unknowns, we should cancel that ratio out. All right, so we can ignore this blue ratio. And then we can solve these two. So when we cross multiply, we get u times sine of 80 is equal to 16 times sine of 41. Again, we're trying to solve for u, so we need to get that by itself. In order to do that, we have to divide both sides by sine of 80. When we do that, we get u is equal to 16 times sine of 41 divided by sine of 80. Questions over that setup? Then we can plug that into a calculator and get an answer. So we need 16 times sine of 41 divided by sine of 80. And then our answer is 10.65. This says round to the nearest tenth, so our answer is 10.7. So the side length of u is 10.7 units long. Okay. Questions about this problem? All right. So your homework is R11. Yes, R11. All right. I'm going to leave this open for the next minute or two. And if you have general questions, I can ask here or I can answer here. If not, if you need a little bit more specific help, I will be in Teams in a meeting, which you can join, and I can kind of help you out individually there. Okay. Um, I highly suggest, because this is new and different, that you start working on this now. And as you have questions, you ask. Okay. That's really how this is supposed to work. Okay. So start working on this. We still have about 35 minutes left in this period. Okay. So take advantage of that, use it. And then if you have questions, I can help you out. Okay. So again, I'll leave this open for the next minute or so. And then if you don't have questions here, I will see you on Teams in the next couple of minutes. All right. So I will close this and I will see you on Teams here in the next minute or two.